We are back with part 2 of graphing rational functions, the day 1 notes. So we're jumping right in. The last two examples to go through. F of x equals x plus 3 divided by negative 2x squared minus 8x minus 6. Again, I personally like to do y-intercepts first. So when I substitute all of my x's with zeros, I get 3 over negative 6, which reduces to negative 1/2. So the y-intercept is 0, negative 1/2. We can now look at the horizontal asymptote. So again, we're looking at the degree of the numerator, x to the first, over the degree of the denominator, negative 2x squared. Since the denominator is the larger degree, then I'm going to have the horizontal asymptote y equals 0. That is the x-axis. All right, now we need to factor so we can get all of the other information. I'm noticing that in the denominator, each of the terms are divisible by 2, and I'm actually going to factor out a negative 2. So this will be negative 2 multiplied by x squared plus 4x plus 3. And now I can further factor that denominator. What multiplies to positive 3 and adds to 4, that's only going to be 3 and 1. So my factors in the denominator are negative 2 and then x plus 3 multiplied by x plus 1. And that numerator still stays the same as x plus 3. Everything in the denominator gives us the domain. Set each of those factors, x plus 3 equal to 0 and x plus 1 equal to 0, and solve for their values. These are the breaks in the domain, either vertical asymptotes and or holes. So I'm going to start always at negative infinity, travel to the first value, negative 3, union between the two numbers, negative 3 to negative 1, union, and that last value, negative 1, out to positive infinity. Now I'm checking for anything left in the denominator that doesn't reduce. So you'll notice I do have a factor, x plus 3, in the numerator and denominator that reduces. That would leave me with a 1 in the numerator and a negative 2 multiplied by x plus 1 in the denominator. Okay, we'll use that to get our holes in just a moment. The factor left in the denominator does become the vertical asymptote. So x plus 1 equals 0, so my vertical asymptote is at x equals negative 1. So I'm going to go ahead and sketch that vertical asymptote. And there we go. X-intercepts. Do we have any values left in the numerator? All right, in the numerator, all I have left is a 1. So there are no x-intercepts. There's no variables there. And you can tie that in with your horizontal asymptote. If the horizontal asymptote is the x-axis, then I can't have any points that are actually plotted on the x-axis, so I won't have any x-intercepts. And last but not least, to determine the hole. So in the hole, the factor that we have that reduced was x plus 3. When I set it equal to 0, I get negative 3 as the x coordinate for the hole. I now need to substitute that into each of the x's left over in the function. So remember, we reduced it a moment ago to be 1 over negative 2 multiplied by x plus 1. So it would be 1 over negative 2 multiplied by negative 3 plus 1. Negative 3 plus 1 is negative 2, and negative 2 times negative 2 is positive 4. So 1/4 is the y value. So my hole occurs at negative 3, positive 1/4. So at negative 3, positive 1/4, that's just barely above the y-axis where that horizontal asymptote is. I really don't have very many points, but you have enough that you can do a very rough sketch. The hole is above y equaling 0, that horizontal asymptote. So to the left, it's going to approach it. And then to the right, it will, from the hole, I'll scurry up, trying to approach the vertical asymptote. And on the right-hand side of the graph, in the bottom right corner, we do have that y-intercept of 0, negative 1/2. So I can drop down and approach the vertical asymptote on the left, and then I will just approach the horizontal asymptote on the right. Great job. We've got one more to practice, and then you guys can work some on your own. Example 7, f of x equals 2 over x minus 3. Y-intercept. I don't have any x's in the numerator, so it's just 2 over negative 3. So it's 0, negative 2/3. Again, just sketch these points as best you can. Somewhere down there close to negative 1 on your y-axis. Okay, horizontal asymptote. We are looking at the degree of the numerator. There are no x's, so that would be like an x to the power of 0 over an x to the first power. So I have a larger degree in the denominator. That means I'll have y equals 0. So again, my x-axis, y equals 0, is my horizontal asymptote. Remember from the last one, if you have a horizontal asymptote at y equaling 0, then you should not have an x-intercept. We'll check when we get there, but just to give you kind of some connections as we go through. All right, domain, vertical asymptote, x-intercepts, and holes. Is there anything to factor? No, thank goodness. This one will be easy. Set your denominator x minus 3 equal to 0 and solve to get x equaling 3. That's the only break in the domain. So my domain is negative infinity to 3 union 3 to positive infinity. Vertical asymptote, I'm looking, does anything reduce in the numerator and denominator? So we have 2 over x minus 3. Nothing reduces. So that means that the factor x minus 3 is set equal to 0 to give me my vertical asymptote. So the break in the domain is the vertical asymptote at x equaling positive 3. Draw that dotted vertical line. There you go. Boundary line, don't cross it. All right, x-intercepts, back to these, double checking. Do I have any variables left in the numerator? Nope. So again, no x-intercepts. We talked about that already. And last but not least, is there a hole? Does anything reduce? Any factors in the numerator reduce with factors in the denominator? None, thank goodness. Awesome. So in this particular example, we have, excuse me, a very easy graph that we can sketch. So from the point where the asymptotes intersect, I can kind of use that coefficient or that value we have in the numerator, treat it like an a value or treat it like a slope. So from the point of intersection, I should be able to go to the right 2, up 1, plot a point, up 2, to the right 1, plot a point, and sketch a beautiful little curve right there. Again, approaching the vertical asymptote to the left, horizontal asymptote falling down to the right. And we should be able to do the same going the opposite direction. We're going to travel to the left 2 and down 1, or down 2 and to the left 1. I should get 2 other good points. Towards the right, it's going to approach the vertical asymptote. To the left-hand side, it's going to pass through the y-intercept and approach the horizontal asymptote. And again, you can use the table to get those other points that I plotted in this particular graph. That is it for our work together. Make sure that you are practicing worksheet G. There aren't very many. They go through all of the steps that we've gone through. You do have a quick quiz this week. Just one problem, just practice graphing. Make sure you got everything down pat. Have a great day, guys.